So I have to mention very clearly. Maybe that's my fault. So I have to mention as session 1 and session 2. But I forgot to mention that session 1 and session 2. Yeah. Right. Okay. So first we will discuss. So today's session is about the properties of various network functions like LC function and RL function and RC function. So first we are going to discuss about the RC network function. Sorry, LC network function. Right. Later we will move to RL and RC. I thought I had on. Yeah, no one in the waiting list, right? So I hope I allowed all the people. Yeah, one. Right. Okay. So first we will discuss about properties of LC network function. That means if the network function is given, then how we can decide whether the given network function is a LC admittance or impedance function or not. Okay. Whether how we can decide, how we can justify whether the given network function is a LC function or not. LC means that means inductor and capacitor. That means that network containing the only inductor and capacitor. So try to understand. Now we are going to discuss about properties of LC network function. LC network function means the network containing only inductor and capacitor, and the network function is either driving point impedance or driving point admittance function of that network, which consists only inductor and capacitor. Okay, so that LC network function is that may be LC impedance function or that may be LC admittance function. Why I am telling LC means that given circuit consists only L and C parameters. There is no R, only L and C parameters are available in that network. If we are calculating the driving point impedance function, that is called as the LC impedance function. If we calculated the driving point admittance function, then we call it as an LC admittance function. So now if we have a network function that may be a impedance function or that may be a admittance function, how we can decide whether the given network function is LC function or not. LC function or not. The first property is whether that is a LC impedance function or LC admittance function. Whether it is a LC impedance function or LC admittance function, that must be a ratio between odd polynomial to even polynomial or even polynomial to the odd polynomial. The first property is the given network function must be the ratio of even polynomial to odd polynomial or odd polynomial to even polynomial. Then we can say that it may be a LC impedance or LC admittance function. That means it may be a LC network function. The given network function is in the form of even polynomial divided by odd polynomial or odd polynomial divided by even polynomial. Hope you understand. Okay. Next, second point. So this first condition we can verify just by inspection method. Just by seeing the network function, we can identify whether it is a ratio between the even by odd or odd by even of the polynomials. That can be verified by inspection. And coming to the second point and coming to the third point, all the roots must be imaginary. That means both zeros and poles must be imaginary. That means the poles and zeros must be interlaced on the j omega axis. Right? Now, second and third condition is, so if we have a network function, so the network function contains the numerator and denominator. So calculate the roots of the numerator, which represent the zeros. Calculate the roots of the denominator, which represent the poles. The zeros and poles must be imaginary. The zeros and poles must be imaginary. So if it is imaginary, definitely poles and zeros are located on the j omega axis or imaginary axis. As the zeros and poles are imaginary, so definitely those are marked on the imaginary axis in the S-plane. At the same time, you have to observe another thing, that is the zeros and poles must be interlaced. The zeros and poles must be interlaced. Interlaced means the zeros and poles will be coming in the alternative fashion. 0 pole, 0 pole, 0 pole, like that. The zeros and poles on the imaginary axis in the S-plane must be interlaced. Nothing but they must come in the alternative fashion. That is the third point. And fourth and fifth points we know, that is highest degree of a polynomial in the numerator and denominator differed by maximum 1, must be differed by 1, not maximum. Okay, na? So small slight change for the PR function and here conditions. So there the maximum difference is 1, but here the must be differed by 1. And similar way, lower degrees of a polynomial in the numerator and denominator must be differed by the 1. So the fourth point and fifth point also can be verified by inspection. And last point is there may be 0 or pole at the origin. There may be 0 or pole at the origin. So here it is telling that it may be. That means this condition not must satisfied. It may be. The 0 or pole may be located at the origin. So these are the 6 parameters or 6 properties. These are the 6 properties for the LC function, and these properties can be helpful for us to identify or to decide whether the given network function is LC network function or not. The first one is the network function must be the ratio of even by odd or odd by even, and all the roots, that means all the zeros and poles must be imaginary. That means they must be located or marked on the imaginary axis of the S-plane. At the same time, the poles and zeros must be coming in the interlace, in the alternative fashion. Similarly, the highest degree difference from the numerator and denominator must be 1, not maximum, must be 1. And the difference between the lower degree in the numerator and denominator must be 1 again. And last point is the 0, there may be a 0 or pole. There may be 0 or pole. Anyone, there may be a 0 or pole at the origin. There may be 0 or pole at the origin. So these properties try to remember. So based on these properties, now we are going to do some exercises. So I am giving the 4 equations here. Now you have to respond whether each equation, each function, network function will represent the LC function or not. Right? Now come to the first case. That first network function is k into s square plus 1 into s square plus 9 divided by s square plus 2 plus s square plus 10. Okay. Now see, I will explain for the first thing, and you have to give the answer for the next 3. So now we will check for the first condition. So this network function must be either even by odd or odd by even. See, so if you expand this one, the first condition is the network function must be the ratio between even by odd or odd by even polynomials. So, okay. So what is the numerator? So numerator is, so let us assume k is a constant, keep aside. S square into s square, that's equal to s power 4 plus 9s square plus 1s square, that's equal to 10s square plus 9. 9 into 1, 9. Right? Similarly, denominator is s to the power of 4 plus 12s square plus 20. So this is the numerator and this is the denominator. Please tell me whether the given network function obeys the first condition or not. First condition, I will show the first condition. Amma?
No.
Yeah, it's no. Because the ratio must be a odd polynomial by even polynomial or even polynomial by odd polynomial. But if you observe NFS divided by DFS, that is the even by even. Even by even. So that means the first condition itself, it was not satisfied, so that the given network function is not a LC network function. It is not a LC network function. It is not a LC network function. Okay, now I hope you understand. So no need to check for the remaining. If we have the total 5 conditions. If any one of the conditions was failed, means no need to check for the remaining, right? So the first given network function is not a LC network function. LC network function. Now, so next we will check for the second network function. We will check for the second network function. So second network function is s power 5 plus 3 into s2 plus 9s divided by 7 into s square plus 6 into s square. 7 into s square power 4 plus 6 into s square. Okay, Nama? Now tell me whether this will be the LC network function or not. We will verify whether the given network function is a LC network function or not.
Odd by even.
Amma? It's LC or not?
Odd by even. Odd by even. It will
So,
satisfy the first one.
S power 5, S power 3, S power 1, S power 4, S power 2. That means odd by even, the first condition is satisfied. First condition is satisfied, right? Now, what about the second condition? All roots must be imaginary. Okay. So first we will check the conditions which we can do by the inspection. Later we move for the calculations. So roots and poles, these are things we require some calculation. Now we will check. Highest power of NFS and DFS must be differed by unity. Highest power must be differed by unity. So highest power entama ikkada 5 kada, ikkada 1 4, so differed by 1, and lowest degree here 1, here 2, that also differed by 1.
By 1.
So that two conditions also satisfied. The two conditions also satisfied. Now we need to calculate the roots. Okay, na? So how we can arrange this one? See, so n of s equal to, so s common this one. Suppose if you take s common, then we have s to the power of 4 plus 3 into s square, 3 multiplied with s square plus 9, right? Sorry, 3 into s square plus 9, right? So is there any possibility to convert into some roots? So s square and coming to
We
this
can
one.
use the form.
Amma?
We can use the formula now, sir. Minus b plus or minus under root of b square minus 4ac by 2.
Right. So we are take s square whole square plus 3 into s square, it's x plus 9, like that, right? So DFS equal to 7 into s square. So if you take s square outside, so if you take s square outside, if you take s square outside, then we have 7 into s square, 7 into s square plus 6, 7 into s square plus 6, right? And because it is a numerator by denominator kada, so the f of x function can be written as if this one by different this one, so this s and s will be cancelled. So we have in the denominator we have 1s, right? So s to the power of 4 plus So s to the power of. So otherwise, I want to keep this one aside because see one thing, Amma, you have to because we don't have much time. So try to convert this equation like in this form. S square plus something I required. So I will try to solve this one at end. Now move to the f of s, third one. Okay, move to the third one. So I will come to this problem at last if we have time. Otherwise, you can also try by yourself. Just try to split like in this form, like s square plus 1 plus s square 9. Like that, you have to split this one. Okay, right. So we will solve, definitely we will solve that one. Now here coming to the f of s, for this one we need to check whether this network function is a LC function or not. How we can check this function is a LC function or not? See, in the numerator we have the s cube plus 4s. The numerator is a s cube plus 4s. That means it is a odd. Where in the denominator we have s to the power 4 plus 4s square plus 4. That is a even. So odd by even, that is a okay.
Even by odd.
This one I am telling. For the this case, s into s square, s cube plus 4 into s. So this is the odd function. And in the denominator we have the s square, s to the power 4 plus 4s square plus 3. Okay. So this is the even function. Otherwise I will write here. So n of s equal to s power 3 plus 4 into s. So this is the odd, and denominator equal to so s to the power of 4 plus 4 into s square plus s to the power of 4 plus 4 into s square plus 3. Sorry, plus 3. So if you observe, it is s power 3 and s power 1 odd, and here s power 4, s square, s power 0 even. So it is a odd by even. Okay, Namma? So it is a odd by even. That means first condition is satisfied. Odd by even, the first condition is satisfied. Next, root difference. Root difference to say what is the higher degree in the numerator, s cube, and higher degree in the denominator, s to the power 4. So maximum higher degree in the numerator and denominator differed by 1, right? Similarly, what is the lower degree here? 4 into s, that is s power 1. So lower degree is a 1. And here what is the lower degree? That is the what is the lower degree? That is a 3. 3 means 3 into s power 0. So lower degree is a 0. Here lower degree is a 1. So again it is differed by 1. Again it is differed by 1. So the fourth condition and fifth condition also satisfied. Fourth condition and fifth condition also satisfied. Right? Next one. Now try to calculate the zeros and poles of the given network function. So what are the zeros? Zeros enti? Zeros means roots of the numerator. Roots of the numerator is 0 because it is so that is a 0, and s square plus 4 equal to 0, s square equal to minus 4.
Plus
Amma?
J2
Plus or minus.
Yes.
plus
So,
J2
plus J2 and minus J2. Okay, Nama? So plus J2 and minus J2, those are the zeros. And what are the poles? Poles are poles in term. Anyone tell what are the
Plus
poles?
J minus J.
Yeah. Plus J and minus J, that means J1. Right? And here plus J
root
root 3. Root 3 plus J root 3 and
plus J root 3 minus J root.
minus J root 3. Right. Okay. So if you observe here, fifth condition also satisfied. What is the fifth condition? Fifth condition is there may be a zero or pole at the origin. There may be a zero or pole at the origin. So 0, 0. So that is at the origin, right? So there is a 0 at the origin. At the same time, there is a 0 at the origin. At the same time, the zeros, remaining zeros and the poles, all are must be imaginary. plus j2
Imaginary.
minus j2 plus j1 minus j1 plus j root 3 minus j root 3. So all the poles and zeros are on the j omega axis, right? Ante kadamma. So plus j2 minus j2 plus j1 minus j1 plus j root 3 plus minus j root 3 and 0. So all are located on the imaginary axis in the S plane. All are located in the imaginary axis in the S plane. So your condition is poles and zeros must be, sorry, all the roots must be imaginary. All the roots must be imaginary. That means that condition also satisfied. All the roots must be imaginary. That condition also satisfied. So what is the remaining? The poles and zeros must be interlaced on the j omega axis. Poles and zeros must be interlaced on the j omega axis. Okay, Namma? Poles and zeros must be interlaced on the j omega axis. So check here. So మనకు పోల్స్ జీరోస్ ఆల్టర్నేటివ్ గా రావాలమ్మా. సో ఫస్ట్ జీరో ఏ జీరో ఉందా ఫస్ట్ ఏమొస్తుంది జీరో వస్తుంది. దట్ ఈస్ ఎట్ ద జీరో. వీ హ్యావ్ ద 1 0 దట్ ఈస్ ఎట్ ద సారీ. ఇప్పుడు ఇమేజ్ యాక్సిస్ ట్రై టు ఐడెంటిఫై హియర్. మీ అదర్వైజ్ ఇక్కడ మనకు ఒక ఆల్రెడీ ఒకటి ఉంటుంది. సాల్వ్ చేయలేదు కానీ మీకు యాక్సిస్ చూపిస్తాను. ఓకే రైట్. సో ఫస్ట్ మనకి ఏమొస్తుందమ్మా 1 0 at the origin. There is a 1 0 at the origin. So there is a 1 0. Here it is a 0 at origin. Okay, Nama? Here there is a 1 0. And another 0 at the plus j2 and minus j2. Plus j2 and minus j2. Plus j2 means let us assume is the 1 and it is a 2. So here I have the 1 0 and at minus j2 that means here I have the another 0. Okay, so these green symbols are represent the zeros. So all the zeros on the imaginary axis of the S plane. On the imaginary axis of the S plane. At the same time I did mark the poles. So poles em vachayamma plus j1 and minus j1. Plus j1 and minus j1. So plus j1 and minus j1 means this is the 2 and this is the 0 somewhere between. That is the pole. So for that, so now pole is at here at plus j1 and also at minus j1. So I will change the color for this one. I will try to change the color for this one. Okay, so this is the plus j1 and minus j1, this is the plus j2 and this is the minus j2 and this is the 0. So green represent the zeros and these red symbols represent the poles. And what are the another poles are remaining? They are if you observe here plus j root 3 and minus j root 3. So root 3 means 1.732. So that means plus j 1.732 and minus j 1.732. That means that another pole must be located between 1 and 0, 1 and 2, right? This is the 1 and this is the 2. In between we have the another pole. That is at the plus j root 3 and here there is a minus j root 3. So now I want to mark it here, somewhere here and also somewhere here, right? That means all the poles and zeros are marked, all marked on the imaginary axis of the S plane, and there may be a 0 or pole. Here it is the 0 located on the origin. So tell me now whether the given network function is a LC function or not.
Yes, sir.
Sindhu cheppandi. It's a LC function or not?
Sir, the interlace is missing.
LC
more.
function.
No, it's not a LC function because out of 6 it's
Because we have
conditions. But see, the third condition is that I think it's the third condition. The third condition, third condition. Poles and zeros must be interlaced on the j omega axis. Interlace means that must be comes in the alternative way. That means 0 pole like that must be comes in the alternative fashion. But see here, 0 pole again it's coming pole. So that means zeros and poles are not coming in the alternative way. So alternative means we must expect if it is a 0, this must be pole, and this again we expect a 0. right? అర్థమవుతుందమ్మా? So we expect 0 pole 0 pole 0 pole like that alternative way, but here see it is a 0 pole and pole comes continuously, not in the alternative fashion. That means the third condition is not satisfied. The third condition is not satisfied. So as the third condition is not satisfied, so the given network function is not a LC function. The given network function is not a LC function, right? Okay, the given network function is not a LC function. Now we will check for the this one last network function. So here the network function is see 2 into s square plus 1 plus s square plus 9 s into s square plus 4. అమ్మ చెప్పండి, ఫస్ట్ కండిషన్ సాటిస్ఫై అవుతుందా లేదా? ఎనీవన్ కెన్ టెల్ ద ఫస్ట్ కండిషన్? అమ్మ
No. Power 4 and power 3.
Yeah, first condition is try to see the first condition. Try to remember first condition. It may be even by odd or odd by even. Even by odd or odd by even. So go here. So what is the numerator? N of s that's equal to n of s that's equal to 2 constant keep aside, s square into s square, that is s power 4 plus 10 s square, sorry 10 s square plus 9. Okay, and whereas the d of s equal to s into s square, that's equal to s cube plus 4 into s, right? So numerator is a s to the power of 4 plus s 10 into s square plus 9 into s power 0. So that is the even polynomial kadamma. So this is the even polynomial, s power 4 s square and s power 0, that is the even polynomial. And whereas the denominator is a s cube plus 4 into s power 1, that is the odd polynomial. So it is the even by odd ratio. That means first condition is satisfied. Whereas second and third and last one we can decide after calculating the roots. Now go to fourth and fifth. The maximum difference between the highest degree in the numerator and denominator must be differed by 1 and lower degree differed by 1. Okay nama? So ఇందులో highest degree ఏంటమ్మా 4, denominator highest degree 3, so difference అనేది 1 ఉంది. Similarly ఇక్కడ lowest degree ఏంటమ్మా s power 0 అంటే 0, ఇక్కడ lowest degree ఏంటి s power 1 అంటే 1, so the difference is again 1. So these two conditions also satisfied. The highest the difference between the highest degree in the denominator and numerator must be 1, and similarly the difference between the lowest degree in the numerator and denominator must be 1. The two conditions also satisfied, right? So later for now we have to calculate the roots. So roots means calculate the roots of the numerator polynomial. Calculate the roots of the numerator polynomial, that is the zeros. Calculate the roots of the numerator polynomial. So roots of the numerator polynomial is called as the zeros. So what are the roots of the numerator polynomial? Roots of the numerator polynomial, nothing but zeros.
Plus j minus j.
Right. Plus j minus j and plus j3
Plus 3j.
minus j3. Right, amma?
Minus 3.
Similarly poles equal to entama 0
0
j2
plus j2
plus
and minus
j2 minus j2.
right, plus j2 and minus j2. Now mark all these things on the imaginary axis, sorry s-plane, on the s-plane. Try to mark all the things in the s-plane. So maybe try to mark all the things in the s-plane. So here, so zeros are plus j1 and minus j1. Here 0 at plus j1 and here it is 0 at minus j1. Okay, nama? And 2 more zeros at plus j3 and minus j3. So 2 more zeros at plus j3. This is j2 kadamma. So plus j3 ante ikkada ekkada untundi. So it is the plus j3 and here it is a minus J3. So in the previous example, I marked the zeros with the green color. So I am trying to change this color as a green, right? Right. And similarly, right. So it is a plus J3 and it is a minus J3. So all zeros are marked. And now poles. Coming to the poles, one pole is at the origin. So see, there is a one pole at the origin. There is one pole at the origin. Sorry. Poles are generally here I am representing with the red color. So one pole at the origin, and what are the another two more poles? That is at the plus J2 and minus J2. So plus J2 means here. So here it is a one pole, and at minus J2 this is the another pole. Okay, Nama? And see, and what about zeros here? Plus J1 and minus J1. So plus J1 and minus J1. So these are zeros. So these are zeros. So zeros we need to mark with the green color, right? And here is also green color. So because it is also 0, plus J1 minus J1, that is also 0. Right. So see, see here. So we have the 4 zeros at plus J1 minus J1 plus J3 minus J3. So plus J1 minus J1 and plus J3 and minus J3, all zeros are marked, and poles are 0 plus J2 minus J2. So at 0 and at the plus J2 and also at the minus J2. That means all poles and zeros are marked, and all the zeros and poles are imaginary, and all the poles and zeros are on the imaginary axis of the S-plane. And see, 0 pole, 0 pole, 0 pole. Now we are going to verify the Z of x equal to into s plus 1 into s plus 3 divided by s plus 2 into s plus 6 is a RC function or not. RC function or not, right? So see the properties. So all the poles and zeros must be located on the real axis, right? So 0, what are the zeros here? Minus 1, minus 3. Poles are minus 2, minus 6, right? So for the second problem, zeros are minus 1, comma minus 3, and poles are minus 2 and minus 6. Poles are minus 2 and minus 6. See, okay, so these are the zeros and these are the poles. Now try to mark them on the S-plane. Try to mark them on the S-plane. So what happened? See. Yeah. Try to mark them on the S-plane. Then we have, right. So zeros are minus 1 and minus 3. Zeros are minus 1 and minus 3. Minus 1 means somewhere here. So this is the minus 1. And minus 3 means laterally the minus 1, somewhere minus 2, somewhere here minus 3. I'm taking minus 3. So these two are the zeros. So zeros we are marked with green color. Just for understanding only, I am marked with the green color. So zeros are with the green color. And what are the poles? And the poles are minus 2 and minus, sorry. Poles are minus 2 and minus 6. Poles are minus 2 and minus 6. So minus 2 will be located here, somewhere here. Because the zeros are minus 1, minus 3. So definitely minus 2 between these two zeros. So minus 2 is located somewhere here. So this is the minus 2. And minus 6 located after somewhere here. This is the minus 6 somewhere here. Minus 6. Okay, then? So all the zeros and poles are the real axis of the S-plane. First condition is satisfied, right? And all the zeros and poles are coming in the alternative fashion. That means 0 pole, alternatively coming. That also satisfied. And 0 must be near to C. 0 must be near to origin. So pole must be near to origin. Pole must be near to origin. So what happened here? Pole must be near to origin. But see, here again 0. Right? 0 is near to origin. So again, it fails the third condition. It fails the third condition. So as it fails the third condition, no need to verify that one. So 0 is near to origin actually, -1. 0 is near to origin. So that's why, but as per the properties, the pole must be near to origin, pole must be near to origin. But if you observe zeros and poles, and 0 is near to origin, 0 is -1, pole is -2. So 0 is near to origin, near to 0, near to origin. So these two functions are not obeys the not the RC functions. Suppose in case suppose if I keep s plus 1 other see 2 3 suppose if I place 7 here instead of 1
Pole is nearer to origin.
Yeah. Suppose if the network function containing the 7 here. Suppose network function containing the 7 here. Then what are the roots? Suppose 1 plus 7 తీసుకున్నాం అనుకోండి. Then this 0 becomes -7. This 0 becomes -7. Then all the roots, all the zeros and poles on the negative, on the real axis, that's satisfied. And also coming in the alternate fashion, -2 pole and 0 -3 and pole -6 and 0 -7. That means pole 0 all are coming in the alternative fashion. Suppose if we take 7 here, alternative fashion, and what is the next condition? Pole must be near to origin. So here pole is near to origin, so -2, that is near to origin, that also satisfied. And 0 must be far away from the origin, that is the -7, that is far away from the origin. So that all four conditions satisfied. Suppose if you consider 7 here, then Z of S will become a RC function. Then Z of S will become a RC function. I hope you understand how we verify the RC function. Okay, so I want to summarize how we verify the given network function is a RC function or not. First of all, for the given network function, try to calculate the zeros, nothing but roots of a numerator polynomial, and also calculate the poles, that nothing but roots of a denominator polynomial. All the zeros and roots must be, all the zeros and poles must be lie on the real axis of the S-plane. Lie on the real axis of the S-plane, at the same time left side of the S-plane. Okay. And next one is all the zeros and poles must be comes in the alternative fashion. That means 0 pole or pole 0 pole 0. That is second condition. Third condition is pole must be located near the origin. And 0 must be located at extreme left in the real axis.